Dear participants, the EFFECT team warmly welcomes you to Module 4b, which aims to provide you an introduction into machine learning and its use in education research. Module 4b should allow you to gain some basic knowledge on machine learning, be able to have a conversation with education economics researchers, and get confronted to a practical application of machine learning in research. Therefore, Module 4b introduces you into fundamental concepts of machine learning, presents some applications of machine learning in current research, and allows you to work on a first case study on machine learning. Dear participants, welcome to Module 4b.1, which is the first module on machine learning. To be able to better define what machine learning really is, let us discuss the fundamental question of machine learning, which is how to build a computer system that can automatically improve its performance with experience. And that's what machine learning actually does. It aims to build a computer system that can automatically improve its performance after having learned with some experience. What could be these performance improvements? These performance improvements could be improved performance at a given task. For example, a machine performing better in speech recognition after having heard the speech of a person several times, or a creation of a completely new ability of the system, such as the recognition of hidden patterns in large data sets. Dear participants, welcome to submodule 4b.2, which is the second submodule on machine learning. In this submodule, we will address a formal definition of machine learning, which is given by the following sentence. A machine learns with respect to a particular task T, performance metric P, and experience E if it reliably improves its performance P at task T following the experience E. This can be represented in the so-called learning model, which is not necessarily limited to machine learning. Imagine how a student learns at school. First, we have the environment, the teacher, that explains a concept to the learner component. The learner then adds this knowledge to his knowledge base and then needs to perform on a test, which is the performance component. Based on how well the student performed at a given test, he will get a performance evaluation, the teacher, for instance, grading him. This provides some feedback based on which the learner can assess how well he has understood the concept and improve afterwards. And machine learning works exactly the same way. We give some information to the learner component, which then enriches his knowledge base, and then the machine tries to perform, gets a response, and automatically improves based on whether the performance was judged well or not sufficient enough. Dear participants, welcome to submodule 4b.3, which is a third submodule on machine learning. In this submodule, we will discuss relevant applications of machine learning for education economics, such as in data analysis, where machine learning is used to find patterns and relationships in large data sets, or to build models, to construct complex models through programming, modify it, and calibrate it with data from the real world. Dear participants, welcome to submodule 4b.4, in which we will do a case study based on machine learning. This case study will be based on the article The Underlying Signals of Efficiency in European Universities, a combined efficiency machine learning approach, published by Dr. Anna Rita Di Piero and Professor Christoph de Witte, who found that main efficiency drivers include higher student fees, the intensity of the PhD programs, and levels of international student mobility. What will particularly interest us in this case study is one particular aspect of their methodology. At some point in their study, Dr. Di Piero and Professor de Witte used a feature selection process, which is a machine learning technique aiming to remove redundant or irrelevant variables. And therefore, the goal of this process is to determine the list of the only variables necessary to predict an analyzed outcome. And this can be achieved by machine learning. This slide shows the two sources that have been used to establish this module 4b. And to conclude, the EFFECT team thanks you for having completed module 4b. If there are any remaining questions, suggestions, etc. regarding this module, please contact Professor Dr. Christoph de Witte, who is the main coordinator of EFFECT and the director of the Lehr Research Group at KU Leuven.